Let's start with what the sun really is, a violent and alien landscape unlike anything we can imagine. Picture this: its surface, a scorching 10,000 degrees Fahrenheit, is a bubbling cauldron of plasma, a strange, electrified soup of matter so hot it doesn't behave like a solid, liquid, or gas. Massive loops of fiery gas, called prominences, erupt thousands of miles into space, dwarfing mountains and continents. And then there are the sunspots, dark, eerie patches that ripple across its face, each one a clue to the restless energy brewing beneath. If you could stand on the sun, which, trust me, you wouldn't want to, it'd feel like stepping into a nightmare of endless explosions, where the ground itself trembles with power. This isn't a quiet campfire in the sky, it's a raging furnace, a star that's been burning for 4.6 billion years and still has secrets we're only beginning to unravel. How do we even begin to know this wild, untouchable place? For centuries, humans gazed at the sun with nothing but their eyes, squinting through smoked glass or watching its shadow dance during an eclipse. They saw a god, a life-giver, a mystery painted in gold. But everything changed when we launched our eyes into space, satellites, those silent sentinels orbiting high above Earth, peering into the sun's soul. In the 1960s, the first solar observatories, like NASA's orbiting solar observatory, gave us blurry glimpses of its surface. Then came the heavy hitters, the SOHO satellite in 1995, a joint effort between NASA and Europe, and later the Solar Dynamics Observatory, or SDO, in 2010. These machines don't just take pictures, they capture the sun in motion, in colors our eyes can't see, revealing flares and storms in jaw-dropping detail. It's like going from a sketch on a cave wall to a 4K movie overnight. Satellites turned the sun from a distant dot into a living, breathing star we could study up close, well, as close as 93 million miles allows. But why does this matter? Why should you, sitting at home with your coffee or scrolling on your phone, care about a ball of fire so far away? Because the sun isn't just a pretty light in the sky, it's a force we urgently need to understand. Think of it as a cosmic ticking clock. Every day, it hums along, keeping our planet warm, growing our food, powering the winds and waves. But it's not always so kind. Beneath its glowing surface, the sun is cooking up trouble that could reach us in ways we're only starting to grasp. Scientists aren't just curious, they're racing against time to decode its rhythms, to figure out what makes it tick, because what they're finding is both incredible and a little terrifying. The sun holds the keys to our survival, and maybe our undoing. That brings us to the hidden dangers of solar storms, nature's way of reminding us who's really in charge. Picture this: a massive explosion on the sun, a flare so bright it could outshine entire galaxies for a moment, followed by a billion-ton cloud of charged particles called a coronal mass ejection, or CME, hurtling toward Earth at millions of miles an hour. When it hits, it's like a punch to our planet's magnetic shield. Most of the time, we get lucky, just a flicker of auroras, those dazzling northern lights dancing across the sky. But sometimes, it's worse. Way worse. In 1989, a solar storm knocked out power to millions in Quebec, plunging them into darkness for hours. Go back further, to 1859, and the Carrington event, a monster storm, set telegraph lines on fire and lit up the night with auroras as far south as the Caribbean. Today? A storm that big could fry satellites, crash power grids, and leave us scrambling in a world that runs on electricity. The sun's tantrums aren't just pretty, they're a threat we can't ignore. And yet, here's the kicker, we're tied to this star in ways that feel almost poetic. We live 93 million miles away, a distance so vast it takes light itself 8 minutes to cross it, and still, the sun is woven into every part of our lives. It's not just the warmth on your face or the green of a forest, it's deeper. Every plant that grows, every fossil fuel we burn, every gust of wind or drop of rain, it all traces back to the sun's energy, captured and recycled over billions of years. Even the atoms in your body were forged in the hearts of ancient stars like it. We're not just neighbors with the sun, we're its children, tethered by an invisible thread across the void. But that connection comes with a catch: its moods can shake us, its storms can break us, and its mysteries keep us guessing. So here we are, staring up at this glowing enigma, a star that's both our lifeline and a wild card. It's a violent, alien place, cracked open by satellites, demanding our attention with every flare and rumble. We need to understand it, not just for the science, but for survival. Because the sun doesn't care if we're ready. It burns on, 93 million miles away, a distant master we can't escape, pulling us into its orbit whether we like it or not. This is just the beginning, a journey into the heart of our mysterious star, where beauty meets danger, and every flash of light holds a secret waiting to be told. As we begin to understand the mysteries of our sun, we must also face its wild and unpredictable outbursts, the powerful solar storms. Hold your breath and picture this: the sun, that golden orb we take for granted, suddenly roars to life, a beast uncaged, its surface splitting open with a flash so fierce it could blind the heavens themselves. On February 15, 2011, that's exactly what happened. The day started like any other, with the sun hanging lazily in the sky, but beneath its glow, chaos was brewing. A solar flare erupted, a blast of light and energy that lit up the cosmos, followed by a monstrous wave of electrified fury, a coronal mass ejection, or CME. Barreling toward Earth like a fist made of lightning. This wasn't just a pretty show, it was a wake-up call, a reminder that the sun doesn't mess around when it decides to flex its muscles. Welcome to the world of solar storms, nature's electric fist, where beauty turns brutal, and our fragile little planet sits right in the crosshairs. Let's rewind to that day, February 15, 2011, a moment etched in the annals of space weather history. Scientists watching through their high-tech telescopes and satellite feeds saw it coming. The sun had been restless, its surface bubbling with dark sunspots like warning lights flashing red. Then, bam, a flare exploded, a surge of X-rays and ultraviolet light screaming across space at the speed of light, hitting Earth in just 8 minutes. But the real punch was still on its way, a CME, a billion-ton cloud of charged particles, plasma hotter than anything we can dream of, tearing through the void at over 1 million miles an hour. It slammed into Earth's magnetic field 2 days later, on February 17, sparking auroras that danced across the night sky, gorgeous greens and purples painting the Arctic. But behind the beauty was a beast, testing our defenses, rattling the invisible shield that keeps us safe. That day wasn't the worst we've seen, but it was a taste, a teaser of the sun's raw, untamed power. How do we even predict something like that? Enter the wizards of space weather, scientists hunched over computers, modeling the incoming CME like detectives piecing together a cosmic crime scene. They start with the flare, tracking its energy signature through satellite data from machines like the Solar Dynamics Observatory. Then they map the CME's path, using math and physics to guess where this juggernaut of plasma will strike. It's like forecasting a hurricane, but instead of wind and rain, you're chasing a storm of magnetic chaos across 93 million miles of emptiness. They build 3D simulations, watching tendrils of solar fury twist and curl, trying to answer the big questions: will it hit us head-on? Will it glance off? How bad will it be? On February 15, they got it mostly right, enough to warn power companies and satellite operators to brace themselves. But here's the kicker: even with all our tech, it's still a game of educated guesses. The sun's a wild card, and we're still learning its rules. So what's really going on when the sun throws these tantrums? Let's break it down. A solar flare is like a gunshot, a sudden, explosive release of energy from the sun's surface, triggered when tangled magnetic field lines snap and reconnect. It's a flashbang of radiation, fast and furious, bathing Earth in X-rays and radio waves that can scramble signals in an instant. But the CME? That's the haymaker, a slower, heavier blow. Imagine the sun hurling a chunk of itself into space, a roiling mass of plasma, charged particles ripped apart into a sizzling soup, guided by magnetic forces like an invisible hand. When it smashes into Earth's magnetic bubble, the magnetosphere, it's a collision of titans. The impact squeezes and shakes our planet's field, sending electric currents surging through the atmosphere. Most times, we get auroras, nature's light show. But when the storm's big enough, those currents don't stop at the sky, they reach down, into our world, and that's where the trouble starts. History's got some scars to prove it. Take March 13, 1989, a day Quebec won't forget. A solar storm, born from a CME, slammed into Earth with such force that it overwhelmed the province's power grid. Transformers fried, circuits overloaded, and in minutes, 6 million people were plunged into darkness. For 9 hours, homes went cold, businesses stalled, and the modern world got a taste of helplessness, all because the sun decided to sneeze. But that was a pebble compared to the boulder of 1859, the Great Geomagnetic Storm, better known as the Carrington Event. Named after Richard Carrington, an astronomer who saw the flare that started it all, this monster storm turned the skies into a carnival of light, auroras blazing as far south as Cuba. Telegraph operators watched in horror as their machine sparked and caught fire, some even sending messages without power, juiced by the sun's electric rage. It was a spectacle, sure, but it was also a warning, a glimpse of what the sun can do when it really lets loose. Now, fast forward to today, and that warning feels more urgent than ever. We're not just talking candles and telegraphs anymore, we've built a world that runs on electricity and orbits on satellites. Picture this, a Carrington-level storm hits in 2025. Power grids collapse, hundreds of millions lose electricity for weeks, maybe months, because transformers don't grow on trees. Satellites fry, knocking out GPS, internet, weather forecasts, everything we lean on. Planes can't navigate, banks can't process payments, hospitals scramble with dying backup generators. It's not sci-fi, it's science fact. Studies say a big enough solar storm could cost trillions of dollars and take years to recover from. Our tech, our phones, our cars, our whole way of life, is a house of cards, and the sun's got a mighty breath. February 15, 2011, was a nudge, 1989 was a shove, 1859 was a shout. What happens when it screams? Here's the wild part, we can't stop it. The sun doesn't care about our power lines or our Wi-Fi. It's been hurling these storms at us for billions of years, long before we strung wires across continents or launched satellites into orbit. We're just latecomers to its game, tiny specks caught in its electric grip. But we're not helpless, not yet. Scientists are watching, modeling, learning, trying to predict the next punch before it lands. Every flare, every CME, is a lesson, a chance to figure out how to shield ourselves from nature's fury. Because the truth is, solar storms aren't just threats, they're marvels. Cosmic fireworks that remind us how small we are, how alive the sun is, and how connected we are to its restless heart. So there it is, the sun's electric fist, swinging through space, ready to dazzle or destroy. February 15, 2011, was just one swing, a spark in a saga of storms that stretches back to 1859 and beyond. From flares to CMEs, from Quebec to Carrington, we've seen what it can do, and we know what's at stake. Our modern world hangs in the balance, fragile against a star that's anything but. This is the sun unmasked, a force of nature that demands our awe, our fear, and our fight to understand it before the next blow lands. To grasp why these solar storms occur, we need to journey deeper into the very heart of the sun and explore its inner workings. Close your eyes and imagine a heartbeat, a pulse so deep, so ancient, it thrums through the cosmos itself, shaking the very fabric of a star. This isn't some distant galaxy secret, this is the sun, our sun, a churning cauldron of fire and fury that's been singing its song for 4.6 billion years. Beneath its blinding surface lies a world we can't see, a labyrinth of forces, a cosmic engine roaring with power, crafting light and life from chaos. For millennia, we've stared at its glow, worshipped its warmth, feared its wrath. But now, we're peeling back its skin, listening to its rhythm, mapping its soul. Welcome to the inner workings of the sun, a journey into the heart of our star, where vibrations hum like a celestial choir and secrets whisper truths that could change how we see the universe forever. Let's start where it all began, humanity's fascination with the sun, a love affair written in stone and story. Picture ancient Egypt, where priests knelt before Ra, the sun god, believing his golden chariot carried life itself across the sky. Or the Mayans, carving calendars so precise they tracked the sun's every move, their temples aligned to catch its rays like sacred handshakes. In Greece, poets sang of Helios, driving his fiery steeds, while in Japan, Amaterasu, the sun goddess, was said to birth the world from her light. Every culture, every corner of Earth, saw the sun as more than a star, it was a mystery, a giver, a god. Even as science dawned, we couldn't look away. Galileo pointed his telescope and saw sunspots, dark blemishes that dared to challenge the idea of a perfect heavens. Newton split sunlight into rainbows, proving it wasn't magic but physics. We've always been drawn to the sun, not just for its warmth, but for the questions it burns into our hearts. What is it? How does it work? Why does it hold us so tightly in its glow? But to know the sun, really know it, we had to go deeper, past its dazzling surface, into the unseen. Unveiling the sun's internal processes is like cracking open a cosmic puzzle box. At its core, the sun is a nuclear furnace, a place so dense, so hot, 15 million degrees Celsius, that atoms can't hold themselves together. Here, hydrogen smashes into hydrogen, fusing into helium in a dance of destruction and creation that releases energy so fierce it powers every ray of light we see. That energy doesn't just sip to the surface, it crawls, twisting through layers of plasma, a strange, electrified fluid that's neither gas nor liquid but something wilder. The sun's not a simple ball of fire, it's a layered beast, each zone a battlefield of forces, gravity pulling inward, fusion pushing outward, locked in a stalemate that's kept it alive for billions of years. To understand it, we had to find a way to see what no eye could touch, to hear what no ear could catch. That's where the sun surprised us again, with a song. In the 1960s, scientists stumbled onto something incredible, the discovery of solar vibrations, sound waves rippling beneath the sun's surface. Picture this, the sun isn't silent, it's humming, trembling with waves of pressure that bounce and echo through its fiery depths. These aren't sounds you'd hear with your ears, they're too low, too vast, but they're real, like the rumble of a distant storm. Researchers noticed tiny shifts in the sun's light, a flicker here, a wobble there, and realized these were clues to what's happening inside. It was as if the sun was whispering its secrets, not in words, but in vibrations, millions of them, overlapping, weaving a symphony of chaos and order. Each wave carries a story, a snapshot of the pressures, temperatures, and movements deep within. This wasn't just a discovery, it was a revolution, a chance to eavesdrop on a star's hidden life. From that spark came the birth of helioseismology, the science of listening to the sun's heartbeat. Think of it as a cosmic ultrasound. By studying these vibrations, scientists learned to decode the sun's inner rhythms. They built instruments, like the Global Oscillation Network Group, or GONG, with telescopes scattered across Earth, watching the Sunday the 24th of July. Satellites like SOHO joined in, catching every flicker of its surface. With supercomputers, they turned those flickers into maps, pictures of a star's insides, drawn not with light but with sound. Helioseismology revealed things we could only dream of: how fast the sun spins at its core, how plasma flows in rivers beneath its skin, even how its magnetic fields twist and turn. It's like giving a doctor an X-ray of a patient. Suddenly, the invisible becomes clear, and the sun's mysteries start to unravel, one pulse at a time. That brings us to the grand payoff: mapping the sun's complex layers, a journey through a star we'll never touch. Let's take the tour. At the core, that nuclear furnace burns, a pinpoint of unimaginable power, just 1% of the sun's volume, but producing all its energy. Surrounding it is the radiative zone, a dense maze where light and heat creep slowly, taking 100,000 years to shuffle outward, bouncing like a pinball in a cosmic machine. Then comes the convection zone, where plasma boils like water in a pot, rising and falling in giant loops that make the sun's surface bubble and churn. And finally, the photosphere, the thin, glowing skin we see, scarred with sunspots and spitting flares. Each layer is a world unto itself, a piece of the puzzle that helioseismology helps us fit together. We're not just looking at the sun anymore, we're walking through it, charting its depths with every vibration, every hum. Here's what makes this so mind-blowing: we're doing the impossible. The sun's core is farther from us than any ocean trench, hotter than any volcano, hidden behind a veil of light so bright it could blind us in a heartbeat. Yet we're mapping it, listening to it, knowing it, not with spaceships or drills, but with patience, math, and a star that sings. This is humanity at its boldest, reaching across 93 million miles to touch the untouchable, to hear the unheard. But it's not just about bragging rights. Understanding the sun's inner workings isn't just cool, it's critical. Those layers, those vibrations, they drive the storms we fear, the flares that threaten our world. Every hum we decode is a clue to predicting the next electric fist, to protecting the fragile life we've built under its gaze. So there it stands, the sun, our mysterious star, no longer just a light in the sky but a living, breathing enigma we're learning to read. From ancient altars to modern satellites, from myths to math, we've chased its secrets across time. Now, with helioseismology, we're hearing its voice, mapping its heart, peeling back its layers one pulse at a time. It's a violent, vibrant world down there, fusing, flowing, humming, a cosmic engine that's been running since before Earth was born. And we're just getting started, standing on the edge of its song, ready to dive deeper into the fire that lights our days and shapes our destiny. Unlocking the sun's internal secrets leads us to follow the incredible, centuries-long journey of a single photon from its core to outer space. Imagine a single spark, a tiny, fearless fleck of light born in the belly of a star, a photon so small it's beyond seeing, yet destined for an epic odyssey across time and space. This isn't just any journey, it's the tale of how the sun's glow reaches your eyes, a saga that starts in a furnace of unimaginable fury and ends with the warmth on your skin. Picture it, a billion photons streaming from the sun every second, each one a traveler, a survivor, carrying the energy of creation itself. This is the journey of a photon, a wild, winding road through plasma seas, nuclear fires, and cosmic chaos, a trip that takes 100,000 years to escape its birthplace and just 8 minutes to find us. Buckle up, because we're diving into the sun's heart, chasing a spark that lights our world and reveals the raw, relentless beauty of our star. First stop, plasma, the fourth state of matter, a realm so strange it feels like the stuff of dreams. Forget solids, liquids, gases, this is something fiercer. Deep inside the sun, matter doesn't play by normal rules. It's a sizzling, electrified soup, a dance of atoms stripped bare, their electrons torn away by heat and pressure until they're a swarm of charged chaos. Picture a glowing ocean, hotter than a million volcanoes, where particles zip and collide in a frenzy. This plasma isn't tame, it's the sun's lifeblood, a wild, shimmering brew that fills its core and flows through its veins. It's what makes the sun glow, what fuels its power, and what traps our photon the moment it's born. Because in this electric wilderness, light doesn't travel free, it fights, it stumbles, it begins a journey more epic than any road on Earth. That journey starts with a bang, nuclear fusion, the sun's core engine, a force so mighty it's the heartbeat of the universe itself. Picture the sun's center, a crushing, searing hellhole, 15 million degrees Celsius, where gravity squeezes matter so tight it's 150 times denser than water. Here, hydrogen atoms, tiny building blocks of the cosmos, slam together with such violence they fuse, becoming helium in a flash of destruction and rebirth. Every collision spits out energy, a photon, a burst of light born from the wreckage. This isn't gentle chemistry, it's a nuclear forge, churning out power that could dwarf every bomb humanity's ever built. In a single second, the sun fuses 600 million tons of hydrogen, turning 4 million tons into pure energy, energy that becomes the light and heat we feel 93 million miles away. Our photon? It's one of those sparks, a newborn warrior flung into the fray, ready to battle its way out. But here's the kicker, the sun doesn't just let it go. Why doesn't this fusion frenzy rip the sun apart, turn it into a supernova that swallows the solar system? It's all about the balance of forces. A cosmic tug-of-war that keeps our star alive. Imagine two titans locked in combat, gravity, pulling inward with a grip that could crush planets, and the pressure of fusion, pushing outward with the fury of 1 trillion explosions. Gravity wants to collapse the sun into a speck, fusion wants to blow it wide open. They wrestle, perfectly matched, holding the sun in a delicate stalemate. If gravity won, we'd be gone, crushed into a black hole. If fusion broke free, the sun would erupt and fade. Instead, they dance, a harmony of destruction that's been spinning for billions of years. Our photon's born in that dance, a child of balance, caught in the chaos of a star that refuses to die. Now the real journey begins, from core to radiative zone, a random walk through a maze of madness. The core spits out our photon, but it doesn't shoot straight to the surface, it staggers, trapped in a sea of plasma so thick it's like wading through molasses. Every step, it slams into particles, bouncing, scattering, zigzagging in a drunken stumble. Picture a pinball machine the size of a star, with a billion obstacles, each collision sends our photon reeling, changing direction, losing a little steam. This isn't a sprint, it's a marathon, a trek that can take 100,000 years, sometimes 1 million, just to crawl a few 100,000 miles. The radiative zone is a twilight world, a dense fog of energy where light creeps, not races, inching outward through sheer grit. Our photon's not alone, trillions of its siblings stumble alongside, a legion of light fighting to break free from the sun's grip. Then comes the convection zone, the sun's bubbling surface, a roiling cauldron that feels alive. After eons in the radiative zone, our photon finally hits this outer layer, where the rules change. Here, plasma doesn't just sit, it moves, rising and falling like boiling water in a cosmic pot. Hot plasma surges upward, cools at the surface, then sinks back down in giant loops, some bigger than Earth itself. It's a churning engine, a conveyor belt of heat that drags our photon along for the ride. The surface, the photosphere, bubbles and spits, scarred with sunspots and flares, a violent frontier where the sun's fury meets the void. Our photon's close now, caught in these rolling waves, until finally, it breaks free, launched into space from a star that's held it captive for millennia. The convection zone is the last hurdle, a wild, bubbling send-off that hurls light into the blackness beyond. And then, the payoff, from core to Earth, a journey of 100,000 years and 8 minutes. After all that struggle, eons of bouncing, battling, bubbling, our photon escapes the sun's surface, a free spark soaring at 186,000 miles per second. The 93 million miles to Earth? A blink, just 8 minutes and 20 seconds, and it's here, splashing across your face, painting the sky blue, warming the ground beneath your feet. Think about that. The light you see right now was born before humans walked the Earth, forged in a nuclear crucible when mammoths roamed and ice-carved continents. It fought its way out, a survivor of a star's chaos, only to race across space in a heartbeat to reach you. Every sunrise, every shadow, every golden glow, it's a gift from a journey older than empires, a story written in light that ties us to the sun's ancient fire. This is the journey of a photon, a tiny hero in a cosmic epic, born in plasma, fueled by fusion, balanced by forces beyond imagining. It's a tale of patience and power, of a star that traps light for millennia only to fling it across the void in an instant. The sun's not just a lamp in the sky, it's a storyteller, whispering its past through every ray that touches us. Our photon's trip, from core to Earth, is a thread in that story, a reminder of the wild, relentless engine that drives our days. And as it lands here, on this pale blue dot, it's just the beginning, a spark that lights the way to everything we are, everything we'll become. As we trace the photon's path, we also discover how modern technology allows us to watch the sun's surface in stunning high definition. Picture this, a window opens to a star, a blazing, churning giant 93 million miles away, and suddenly, you're not just looking, you're witnessing, frame by frame, the sun's wild dance of fire and fury in crystal-clear detail. This isn't a blurry sketch or a painter's dream, this is the sun unmasked, it's every flare, every ripple, every scar captured in high definition like a blockbuster movie playing out in real time. On February 11, 2010, humanity flipped the switch on a new era, launching a machine that turned our hazy glimpses into a front-row seat to the cosmos. This is the story of watching the sun in high definition, a tale of technology and wonder, of beauty and danger, where every pixel reveals a star that's more alive, more ferocious, and more unpredictable than we ever dared imagine. That machine? The Solar Dynamics Observatory, or SDO, a marvel of human ingenuity that rewrote the rules of solar science. Picture a spacecraft the size of a small bus, bristling with cameras and sensors, blasted into orbit on a rocket's fiery tail. Its mission, to stare at the Sunday the 24th of July, unblinking, relentless, catching every twitch of its surface from 22,000 miles above Earth. Launched by NASA, the SDO wasn't just another satellite, it was a game-changer, a sentinel armed with tech so advanced it could snap a picture every second, in resolutions 10 times sharper than your TV at home. Before SDO, we had snapshots, like old Polaroids of a restless beast. After? We got a live feed, a high-def window into a star that's been burning for billions of years. This was no small step, it was a leap into a new age, where the sun's secrets couldn't hide behind its blinding glow anymore. And oh, the sights it revealed. Stunning images of the sun's surface that could steal your breath and break your heart with their beauty. Imagine this, a sea of golden plasma, swirling and bubbling like a witch's brew, stretched across a disk 109 times wider than Earth. The SDO's cameras catch it all, towering loops of fire, called prominences, arching thousands of miles high, glowing like neon against the void. Sunspots, those dark, brooding patches, pulse and shift, each one a magnetic storm brewing in plain sight. Flares erupt, sudden and savage, spitting light so bright it could outshine the stars. Every image is a masterpiece, granules the size of countries rippling like waves, filaments of plasma twisting like cosmic serpents. It's not just science, it's art, a gallery of a star's raw soul, painted in colors and details we'd never seen before. The sun's surface isn't static, it's alive, and SDO shows us every heartbeat. But here's where it gets wilder. Observing in multiple wavelengths turns the sun into a kaleidoscope of chaos. The SDO doesn't just see in the light we know, it peers into the invisible, capturing the sun in ultraviolet, extreme ultraviolet, even X-rays. Each wavelength is a key, unlocking a different layer of the story. In visible light, you see the photosphere, that bubbling skin we call the surface. Shift to ultraviolet, and the chromosphere glows, a fiery halo of plasma tendrils. Crank it to extreme ultraviolet, and the corona blazes into view, a crown of million-degree heat that defies logic. X-rays? They spotlight the hottest, most violent eruptions, flares and storms caught mid-roar. It's like flipping through filters on a cosmic camera, each one revealing a sun more alien, more ferocious, more mesmerizing. Together, these wavelengths weave a tapestry of a star in motion, a multicolored symphony of light that's as beautiful as it is brutal. That beauty peaks when SDO captures solar storms across the sun's entire disk, a front-row ticket to nature's electric fireworks. Picture a flare igniting on one edge, a flash so intense it's like a gunshot in the dark, followed by a coronal mass ejection, a billion-ton cloud of plasma ripping free, streaking across the sun's face in real time. The SDO doesn't miss a thing. It tracks the storm's birth, watches it twist through magnetic loops, sees it blast into space, all while holding the whole sun in its gaze. No telescope on Earth could do this, the atmosphere blurs and blocks too much. But up there, in orbit, SDO sees it all, flares blooming like flowers of fire, CMEs surging like tidal waves, auroras born from their fallout lighting up our skies. Every storm is a spectacle, a high-def drama of destruction and wonder, and SDO's the director, filming every second of the chaos. Yet here's the rub, for all this brilliance, there's a shadow. The challenge of predicting solar impacts keeps us on edge. The SDO's images are a treasure trove, showing us when and where storms ignite, how big they grow, how fast they move. Scientists pore over the data, tracing magnetic twists, clocking plasma speeds, trying to guess where the next punch will land. Will that CME slam Earth head-on, frying satellites and blacking out cities? Or will it graze us, leaving just a shimmer of auroras? It's a high-stakes puzzle, because even with SDO's eagle eyes, the sun's a trickster. Its storms twist unpredictably, guided by forces we're still decoding. A flare might look tame in one wavelength, then explode in another. A CME might veer off course, sparing us, or double back, catching us blind. Prediction's an art as much as a science, and every miss reminds us we're watching a beast we can't fully tame. Think about that for a second. We've built this incredible machine, this SDO, a sentinel that turns the sun into a live show, every flare a cliffhanger, every storm a plot twist. It's given us eyes sharper than ever, peeling back the sun's layers in ways our ancestors couldn't dream of. But it's not just about the wow factor. Those high-def glimpses are lifelines, clues to when the sun might turn its electric fist our way, threatening the fragile world we've wired together. The stakes are sky-high: power grids, satellites, communication, all hang in the balance of what SDO sees. It's a race against a star that doesn't care, a battle to understand its rhythm before the next big hit. So here we stand, gazing through SDO's lens, watching the sun in high definition, a star laid bare, its surface a canvas of fire, its storms a theater of power. This isn't just observation, it's revelation, a chance to know the sun not as a distant dot, but as a living force that shapes our days and tests our limits. From stunning images to wavelength wizardry, from storm chasing to prediction struggles, the SDO pulls us closer to a mystery we've chased for millennia. It's a new era, all right, a dazzling, dangerous one, where every frame reminds us, the sun's not just up there. It's in us, around us, and thanks to this high-def marvel, right in front of us, burning brighter than ever. Behind these mesmerizing images lies an invisible but powerful force, the sun's magnetic secrets, shaping everything we see. Picture a force you can't see, can't touch, a ghostly puppeteer pulling strings across a star, twisting fire into chaos, hurling storms into the void. This isn't some sci-fi phantom, this is solar magnetism, the sun's hidden heartbeat, a power so wild it shapes every flare, every eruption, every whisper of light that reaches us. Beneath that golden glow lies a secret dance, a magnetic ballet of beauty and destruction, where invisible lines of force weave a web that can cradle life or shatter worlds. We're 93 million miles away, basking in its warmth, yet tethered to a star that's alive with currents we're only beginning to unravel. Welcome to the magnetic secrets of the sun, a journey into an unseen realm where plasma glows, fields twist, and the cosmos itself bends to a rhythm older than time. Let's start with the invisible force, solar magnetism, the sun's silent maestro. You'd never guess it, staring at that bright disk in the sky, but the sun's a magnetic monster. It's not just heat and light, it's a swirling sea of charged particles, plasma so hot and restless it generates fields of power that ripple through its depths and stretch into space. These aren't puny magnets like the ones on your fridge, they're titanic, stretching thousands of miles, strong enough to lasso loops of fire or snap like cosmic whips. Sunspots, those dark, brooding scars, mark where these fields punch through the surface, twisting and tangling in a fury we can barely fathom. This isn't a calm, orderly star, it's a battlefield, where magnetism reigns supreme, an unseen king directing every move in a drama that's been playing for 4.6 billion years. How does it even happen? Enter the sun's dynamo effect, a cosmic engine that spins chaos into power. Picture the sun as a giant blender, its layers churning at different speeds. Down deep, the core spins fast, while the outer edges lag behind, a dance of plasma that twists and stretches like dough in a baker's hands. Inside that motion, charged particles flow, billions of them, creating electric currents that birth magnetic fields. It's like a generator the size of a star, powered by heat from the core and the sun's relentless rotation. Scientists call it the dynamo because it's alive, pulsing, building magnetic energy that coils tighter and tighter until it's ready to break free. This isn't random, it's a cycle, an 11-year heartbeat that swings from quiet to chaos, driving the sun's moods and painting its face with storms. The dynamo's the spark, the unseen hand that turns a ball of fire into a magnetic marvel. And when that spark ignites, you get twisting magnetic field lines and the birth of solar flares, a fireworks show with a punch. Imagine those fields, stretched like rubber bands across the sun's surface, looping through sunspots where the magnetism's strongest. They twist, they tangle, pushed by the dynamo's relentless churn, until they can't hold anymore. Snap, they reconnect in a flash of violence, releasing energy so fierce it's like a million nuclear bombs going off at once. That's a solar flare, a blast of X-rays, ultraviolet light, and charged particles, born from magnetic chaos, lighting up the sun's face in a heartbeat. It's sudden, savage, beautiful. A flare can hit Earth in 8 minutes, scrambling radio waves, dazzling the sky with auroras. The SDO catches them in high-def glory, but it's the twisting fields, invisible until they break, that write the script for every explosive act. That's just the opening number. Plasma illuminates the magnetic dance, turning the invisible into a glowing spectacle. This plasma, the sun's electrified blood, doesn't just sit there, it flows, guided by those magnetic lines like iron filings tracing a magnet's pull. Picture it. Massive arches of fire, called prominences, leap from the surface, held aloft by magnetic loops, glowing red-hot against the black of space. Filaments twist and shimmer, plasma trapped in a magnetic cage, lighting up the sun's secrets for us to see. When the fields shift, the plasma moves, rising, falling, erupting, revealing the dance beneath. It's a neon sign of the sun's power, a tracer that lets us watch magnetism in action. Every flare, every prominence, is a spotlight on the invisible, a plasma brush painting the sun's magnetic soul across its fiery canvas. Then comes the grand finale, coronal mass ejections and the magnetism behind them, the sun's ultimate power play. If flares are the jab, CMEs are the haymaker. Picture those twisted field lines snapping not just once, but in a chain reaction, hurling a billion-ton cloud of plasma into space at millions of miles an hour. That's a CME, a magnetic storm born from the same dynamo that fuels the flares, but bigger, badder, a juggernaut of charged chaos. The magnetism doesn't just spark it, it shapes it, flinging plasma along field lines like a slingshot, aiming it across the void. When it hits Earth, it's a magnetic brawl, our planet's field clashing with the sun's, sparking auroras or frying power grids. The 1859 Carrington event? A CME so massive it was magnetism's masterpiece, a reminder of what those invisible forces can unleash when they cut loose. Here's the wild part. This magnetic mayhem isn't just pretty, it's personal. Those fields, that dynamo, those twisting lines, they're why the sun can reach out and touch us 93 million miles away. A flare can scramble your GPS, a CME can black out your city. But they're also why it's alive, why it burns, why it breathes, why it's more than a lifeless lump of gas. Magnetism's the sun's pulse, the secret source that turns fusion's raw energy into a star that dances, flares, and fights. Scientists watch it with satellites, trace it with models, chase it with every tool we've got, but it's still a mystery, a force we're racing to understand before the next storm strikes. So there it is, the magnetic secrets of the sun, a realm of invisible power that shapes a star and shakes our world. From the dynamo's churn to the flare's flash, from plasma's glow to the CME's roar, it's a dance of forces we can't see but can't escape. This isn't just physics, it's poetry, a cosmic ballet where every twist of magnetism writes a story of beauty and danger. The sun's not just a light in the sky, it's a magnetic titan, weaving a web that binds us to its fiery heart. And as we peel back its secrets, one flare at a time, we're reminded, this star's got moves we're only starting to catch, and its next step could change everything. Magnetism doesn't just sculpt the surface, it also fuels the mystery of the sun's hottest, most puzzling layer, the solar corona. Imagine a crown of fire, a shimmering, ghostly halo wrapped around the sun, so faint you'd miss it unless the moon stepped in to block the glare. This isn't the sun's surface, that blazing sea of plasma we've come to know. This is the corona, a realm so strange, so wild, it defies everything we think we understand about stars. Picture this, a veil of light stretching millions of miles into space, hotter than the fires below, hiding power that could swallow planets whole. It's the sun's secret weapon, a mysterious shroud that dances in the dark, whispering riddles we're still scrambling to solve. Welcome to the mysterious solar corona, a journey into an atmospheric enigma where heat soars, jets roar, and the sun's true might waits to be unleashed. Let's dive into the heart of the mystery, the hotter-than-surface puzzle, a cosmic conundrum that's been twisting minds for decades. You'd think the sun works like a campfire, hot at the center, cooler as you move out. The surface, the photosphere, burns at a scorching 10,000 degrees Fahrenheit, fierce enough to melt steel in a blink. But step into the corona, and the rules shatter. Out here, millions of miles above that bubbling skin, temperatures rocket to 2 million degrees, sometimes 20 million, a heat so insane it could vaporize anything we've ever built. How? Why? It's like finding a bonfire's flames cooler than the air a mile above it. Scientists call it the coronal heating problem, a puzzle that mocks our logic. The sun's hiding a trick up its sleeve, a secret furnace in its outer reaches, and cracking it means rethinking everything we know about the star that lights our days. So what's stoking this inferno? Enter plasma jets, heating the corona with bursts of fiery chaos. Picture tiny explosions peppering the sun's surface, little geysers of plasma blasting upward like rockets on a mission. These jets, some call them spicules, shoot out at speeds of 60,000 miles an hour, carrying heat and energy into the corona's vast expanse. They're born in the churning convection zone, where magnetic fields twist and snap, flinging plasma skyward in a relentless barrage. Millions of these jets erupt every day, a cosmic fireworks show too small to see without high-tech eyes like the SDO's. Scientists think they're part of the answer, each jet a spark, dumping energy into the corona, stoking its million-degree blaze. It's like 1,000 campfires feeding a wildfire, a swarm of tiny heroes lighting up a mystery we're only starting to chase. But the jets are just the warm-up. The real fireworks come with energy release and CME acceleration, the corona's explosive encore. Those magnetic fields we've been tracking? They don't just sit pretty in the corona, they tangle, they twist, they build tension like a coiled spring. When they snap, bam, you get a flare, a flash of light and radiation. But sometimes, the release is bigger, wilder, and the corona unleashes a coronal mass ejection, a CME, a billion-ton monster of plasma hurled into space. The corona's heat and magnetism turbocharge it, accelerating this beast to millions of miles an hour, turning it into a solar storm that can slam Earth with a vengeance. It's not just energy, it's a chain reaction, a magnetic meltdown that starts in the corona's depths and ends with auroras or blackouts. The SDO catches these moments, flares blooming, CME surging, a high-def glimpse of a power that's been brewing in the sun's crown all along. That power? It's the immense power hidden in the sun's atmosphere, a force so vast it's almost unthinkable. The corona isn't just a pretty halo, it's a dynamo of destruction and wonder, a reservoir of energy that dwarfs the surface below. Think about it, a single CME carries enough juice to power Earth for years, enough punch to fry satellites and grids in a heartbeat. During a total eclipse, when the corona glows like a silver ring, you're seeing a glimpse of that might, a crown that stretches millions of miles, shaping the solar wind, sculpting the heliosphere that shields us from cosmic rays. It's the sun's outer fist, a million-degree juggernaut that can reach across space and shake our world. The 1859 Carrington event? That was the corona flexing, a reminder of the Titan lurking in plain sight, waiting to roar. Here's what makes it jaw-dropping: the corona's a paradox, a faint, fragile glow that's stronger than steel. You can only see it when the sun's disk hides, during an eclipse or with special scopes. Yet it's the source of the sun's most ferocious tantrums. Scientists are obsessed, launching probes like the Parker Solar Probe, diving closer than ever to taste its heat, measure its fields, solve its riddles. Why is it so hot? How do jets and magnetism team up to fuel it? Every answer's a step closer to predicting the next big storm, to shielding our tech from the corona's wrath. But every question's a thrill, too, a chance to peel back a layer of a star that's been teasing us since we first looked up. This isn't just science, it's a saga. The corona's heat defies reason, its jets dazzle, its CMEs terrify, and its power humbles. It's the sun's wild card, a crown of chaos that's been there all along, hiding in the glare, whispering secrets in every flicker of light. We're 93 million miles away, safe in its glow, yet at the mercy of its mood. The mysterious solar corona isn't just an atmosphere, it's a battlefield, a furnace, a marvel that ties us to the sun's deepest truths. And as we watch it flare, as we chase its heat, we're reminded, this star's got layers we're only beginning to touch, and its crown might just hold the key to it all. To protect our world from the sun's fiery moods, scientists race to predict the behavior of these extreme and often unpredictable forces. Imagine staring into the face of a beast, a star that growls with fire, its mood swinging from quiet to chaos, its next move a gamble that could light up the sky or plunge us into darkness. This is the sun, our cosmic overlord, 93 million miles away, and we're trying to guess its temper tantrums before they hit. Predicting solar storms isn't just a science, it's a high-stakes chase, a dance with a star that doesn't play by our rules. We've got clues scribbled across its surface, rhythms pulsing through its core, and a history of havoc to guide us. But every forecast is a roll of the dice, a peek into a future where beauty and danger collide. Welcome to the wild world of predicting solar storms, a tale of sunspots, cycles, and magnetic mayhem, where the sun's next punch keeps us guessing and the stakes couldn't be higher. Let's start with the first breadcrumbs, sunspots, the warning signs etched on the sun's fiery skin. Picture these dark, brooding patches, some bigger than Earth, scarring the photosphere like omens in a prophet's vision. They're not just blemishes, they're magnetic hotbeds, places where the sun's invisible field lines twist so tight they choke the heat, dimming the glow to a cool 7,000 degrees amid the 10,000-degree blaze around them. Galileo spotted them 400 years ago, proving the sun wasn't perfect, but today, they're our crystal ball. More sunspots mean more action, flares, CMEs, storms brewing in the chaos. A quiet sun might show a handful, a restless one, hundreds. Scientists count them daily, watching through telescopes and satellites, knowing each dot is a ticking clock, a hint that the sun's gearing up to throw its electric fist our way. That rhythm isn't random, it's tied to the 11-year solar cycle, a cosmic heartbeat of maximums and minimums that's been thumping since the sun was born. Imagine the sun as a pendulum, swinging between calm and fury every decade or so. At solar minimum, it's sleepy, few sunspots, tame magnetic fields, a star catching its breath. Then comes the climb to solar maximum, a peak of pandemonium where sunspots swarm, flares flash, and CMEs rocket into space. Cycle 25, hitting its max around 2025, is what we're riding now, a rollercoaster of activity that could dazzle or devastate. Astronomers tracked this pulse back to the 1700s, charting 24 cycles, each one a story of quiet lulls and roaring highs. It's like the sun's breathing, inhaling peace, exhaling chaos, and every 11 years, we brace for the exhale, hoping we've read its mood right. But there's a twist in this tale, magnetic pole reversals and solar personalities, the sun's wild identity crisis. Halfway through each cycle, around solar max, the sun flips its script, its north magnetic pole becomes south, its south becomes north, a cosmic somersault that rewires its entire field. Picture those tangled magnetic lines, built by the dynamo we've tracked, stretching and snapping until they collapse and reform, reversed. It's not just a trick, it's a reset, a shift that can calm the storm or spark a frenzy. Every cycle's got a vibe, a personality. Cycle 19 in the 1950s was a beast, spitting the biggest flare ever recorded. Cycle 23 in the 2000s through the 2003 storms that rattled our grids. Scientists watch these flips, these moods, knowing each sun is unique, a star with a temper we're still learning to read. That's where the real fight kicks in, space weather prediction challenges, the art of outguessing a star that loves to surprise. Think of it like forecasting a hurricane, but this one's 93 million miles away, invisible until it strikes. Satellites like SDO give us the raw footage, sunspots blooming, flares igniting, CMEs launching, while computers crunch the data, tracing magnetic twists and plasma speeds. Will that CME hit Earth? How hard? When? It's a puzzle with missing pieces. A flare's X-rays reach us in 8 minutes, frying radio signals before we blink. A CME might take days, its path a curveball shaped by magnetic whims we can't fully map. The 2011 storm grazed us, 1989's hit square on, 1859's was a bullseye we're still reeling from. Every miss costs credibility, every hit costs billions, satellites, power grids, lives in the balance. Here's the kicker, we're getting better, but we're not there. Scientists use alioseismology to peek inside, SDO to watch the surface, probes like Parker to taste the corona's edge. They've nailed some calls, warning grids before the 2003 storms, prepping satellites for 2011's unrest. But the sun's a trickster. A quiet cycle can suddenly roar, a busy one can fizzle. Magnetic fields twist unpredictably, storms veer off course, and our models, fancy as they are, still guess as much as they know. It's a race against a star that doesn't care, a chase to shield our tech, our world, from a force that's been hurling chaos since before we lit our first fire. Think about that, we're tiny specks, betting on a giant. Sunspots are our flares in the dark, the 11-year cycle our metronome, pole flips our wild card. We've turned telescopes into crystal balls, satellites into sentinels, trying to crack a code written in fire and magnetism. Every prediction's a triumph, or a lesson. The sun doesn't wait, it burns, it flips, it storms, and we're along for the ride, 93 million miles from its heart, but right in its crosshairs. This is predicting solar storms, a cosmic game of cat and mouse, where the stakes are our skies, our power, our future, and the sun's always one step ahead, grinning with its electric teeth. So here we stand, eyes on the sun, counting its spots, tracking its pulse, chasing its storms. It's a dance of danger and wonder, a star we can't control but can't ignore. From maximums that dazzle to minimums that tease, from reversals that rewrite it to forecasts that test us, the sun's a riddle we're dying to solve. And as we watch, as we predict, we're reminded, this isn't just a light in the sky, it's a force with a mind of its own, and its next move could be the one that changes everything. History offers us sobering lessons, revealing that some solar storms have been so massive, they reshaped civilization, as seen in the greatest solar storm ever recorded. It was a time before electric cities. A time before smartphones, satellites, and the invisible web of signals that now threads through every breath of our lives. And yet, even then, the sun made itself terrifyingly known. In the waning days of summer in 1859, as the world carried on with the simple hum of the industrial age, a strange and haunting phenomenon unfolded in the skies above. It began quietly, innocuously, a sudden brightening on the surface of the sun, captured by the careful gaze of a solitary astronomer, Richard Carrington. Peering through his telescope on that fateful September morning, Carrington witnessed two patches of blinding white light erupting from a dark sunspot. He had no way of knowing that in that instant, he was watching history's greatest solar storm announce its arrival. The brilliant flashes he observed were no mere curiosities. They were the first signatures of an immense cataclysm, a titanic solar flare that hurled a monstrous wave of charged particles hurtling toward Earth at unimaginable speed. In less than a day, an astonishing velocity by cosmic standards, the solar tempest struck. And when it struck, the world trembled. Night became an otherworldly spectacle. Across the globe, from the equator to the poles, the heavens ignited in ghostly veils of green, red, and purple. The northern lights, normally confined to the farthest reaches of the Arctic, descended upon the tropics, bathing cities like Havana and Rome in an eerie, ethereal glow. People awoke in the middle of the night, convinced that dawn had come early, that perhaps Judgment Day itself was at hand. But beauty was only the surface of the storm. Telegraph wires, the arteries of human communication at the time, erupted into chaos. Sparks flew from transmission lines. Operators received electric shocks simply by touching their instruments. In some cases, telegraph systems continued to operate even after being disconnected from their power supplies, driven by the sheer ferocity of the geomagnetic energy enveloping the planet. It was a cosmic reminder, a revelation both humbling and profound, that beneath the thin, fragile skin of human achievement, there still loomed forces vast, ancient, and indifferent to our designs. The Carrington event, as it came to be known, was a catastrophic warning, a cosmic telegram unbidden and unforgettable. And yet, in 1859, the world was lucky. Humanity had not yet woven itself into the delicate tapestry of electricity and information that defines modern life. Telegraph lines burned, yes, but cities did not fall. Economies did not collapse. Civilizations did not grind to a halt. But if such a storm were to strike today, the consequences would be catastrophic beyond imagining. Today, we live suspended on an invisible web, a network of satellites orbiting above, a lattice of electrical grids sprawling across continents, a ceaseless exchange of data racing at the speed of light. Each pulse of information, each spark of energy, is a heartbeat in the living organism of modern civilization. And all of it, could be undone by the sun's wrath. A solar superstorm like the one Carrington witnessed would devastate our world. Satellites would be the first to fall, their delicate circuits fried by invisible tides of radiation. Global positioning systems would fail. Communications would shatter. The very infrastructure that guides aircraft, ships, and emergency services would be plunged into darkness. Down on Earth, power grids would falter and die. Transformers would melt under the onslaught, igniting fires and blacking out entire nations. Banks, hospitals, water supplies, and emergency services, all would be paralyzed. In mere hours, the thin thread of modern life could unravel into confusion, desperation, and collapse. And recovery would not be swift. Repairing the massive transformers that form the backbone of our power systems could take months, perhaps years. In a society that depends on just-in-time delivery for everything from food to medicine, even a few days without power could unleash cascading crises unlike anything we have ever seen. It is a chilling irony. The very marvels that define our age, the technologies that connect, empower, and elevate us, are also our greatest vulnerabilities. The sun, ancient giver of life, could just as easily become the architect of our undoing. Yet we have not been left entirely defenseless. Scientists now watch the sun with an intensity unimaginable in Carrington's time. Space weather forecasting, early warning systems, and emergency protocols stand ready, yet even so, our ability to mitigate a true solar superstorm remains limited. Time itself would be the ultimate weapon, hours, perhaps a day's warning at best, to prepare for a disruption that could change the course of human history. The question is not if such a storm will come again. It is when. The sun, in its majesty and violence, follows cycles older than civilization. And within those cycles lies the certainty of future tempests. Somewhere, far above the placid blue of our skies, magnetic fields twist and coil in silent fury, building toward an inevitable release. We live in the quiet between storms, suspended in a fragile golden age of light and power, too often unaware of how quickly it could all be taken away. Perhaps, if we listen, if we remember the strange auroras that once danced over Havana, the telegraph lines that once burned with fire from the heavens, we can prepare. Or perhaps, like our ancestors, we will one day look to the sky in wonder and terror, as the sun once more reminds us that in the grand scale of the cosmos, we are, and have always been, small. Living under the shadow of such threats reminds us how deeply Earth's fate is tied to the sun's every move. We live suspended in a delicate, ever-shifting balance between survival and catastrophe, between sunlight's nurturing warmth and its untamed fury. Every breath we take, every electronic pulse that zips invisibly across our modern world, exists by the grace of an unspoken agreement, an ancient and fragile truce with the star that birthed us. But sometimes, the sun reminds us just how tenuous that agreement really is. In the waning days of October 2003, as the world prepared for the usual festivities of harvest and Halloween, something ancient and furious stirred in the heart of the sun. A tempest began to brew, a series of solar eruptions so immense they would become etched into history as the Halloween storms. Massive sunspots, each many times larger than Earth itself, twisted and churned across the solar surface. The magnetic fields above them, tangled and taut like the strings of an enormous cosmic instrument, finally snapped, releasing titanic flares of radiation and coronal mass ejections that ripped through space at 1,000,000 miles an hour. In the days that followed, the Earth's magnetic shield was battered again and again by wave after wave of solar assault. Power grids groaned under the sudden electrical surges, spacecraft malfunctioned and went blind, GPS systems flickered and wavered as if drunk on the cosmic fury, airlines had to reroute flights away from polar routes to protect passengers from radiation exposure. Even the northern lights, normally a quiet ballet in the polar skies, exploded into wild, writhing displays seen as far south as Texas and the Mediterranean. For those who understood what was happening, it was a sobering revelation: we are not the masters of this planet. We are passengers. We are dreamers perched precariously on the shores of a vast, volatile sea. And sometimes, that sea sends waves that reach far beyond the horizon of our understanding. The Halloween storms of 2003 were not a cataclysm. But they could have been. And they served as a grim rehearsal for a disaster far greater, lurking quietly in our future. The truth is that Earth and Sun are locked in an endless, invisible dance, a cosmic waltz that has lasted billions of years. The Sun spins and breathes, it exhales great gusts of charged particles known as the solar wind. And the Earth, wrapped in its magnetic cloak, spins within that wind like a ship tossed on subtle but relentless currents. It is a dance full of grace, but also danger. A misstep, a sudden, violent storm from the sun, could send that wind howling against our world with enough force to tear apart the delicate filaments of civilization itself. And yet, even as we confront these threats, something even more alarming is unfolding, not in a sudden flare, but in a slow, almost imperceptible shift. Our cosmic shield, the heliosphere, is shrinking. The heliosphere, an immense bubble of charged particles and magnetic fields inflated by the solar wind, protects not just Earth, but the entire solar system from the harsh bombardment of cosmic rays that stream through the galaxy. It is our first line of defense against the cold, deadly radiation of interstellar space. But the sun, like all living things, goes through cycles of strength and weakness. In recent decades, astronomers have observed a troubling trend. The solar wind has been weakening. The boundary of the heliosphere has been contracting inward, drawing closer to the fragile inner planets like a fortress whose walls are crumbling. As the heliosphere shrinks, more and more cosmic rays are able to penetrate into our neighborhood and onto our planet. High-energy radiation from distant, dying stars now bombards our atmosphere in ever greater quantities, slipping through the gaps in our defenses. The consequences are not just abstract, they ripple down to the ground where we live, affecting satellite electronics, influencing weather patterns, and perhaps even playing a subtle role in the evolution of life itself. The weakening solar wind signals a vulnerability that we cannot ignore. It is a cosmic whisper, growing louder with each passing year. The walls are thinning, the storms are gathering, and we, the dreamers of Earth, must reckon with the forces that have shaped and threatened life since the beginning. We live at the mercy of the sun, and always have. It is a truth both humbling and awe-inspiring. Our world, with all its cities, its technologies, its dreams and ambitions, spins in the fragile cradle of space, its fate forever tied to the moods of the vast, roaring furnace at the center of our solar system. And as we look toward the future, into a century where humanity will stretch further into space and build even more elaborate digital empires, we must never forget that it all rests upon a fragile balance, a balance that can be upset in a single, furious breath from the star we call home. Yet even as we monitor the sun's effects on Earth, we continue looking outward, to the edges of our solar system and beyond. When we lift our eyes to the night sky, we see a tapestry of stars stretched across a sea of black, a view so vast, so infinite, that it stirs something ancient in the human soul. It is easy, when staring into that endless dark, to feel small, to feel isolated. Yet, hidden within that darkness is a truth both astonishing and profound: we are not adrift without shelter. We are cradled within the invisible embrace of the sun. The sun, in all its radiant power, does not merely light our days and warm our world. It builds a protective cocoon around us, an unseen fortress known as the heliosphere. A great bubble, inflated by the solar wind, shielding us from the icy, lethal radiation that flows through the interstellar abyss. But where, exactly, does our sun's influence end? Where does the fortress wall meet the wilds beyond? To answer that ancient question, humanity reached for its most audacious tools. And among them was IBEX, the interstellar boundary explorer. Launched into orbit in 2008, IBEX was tasked with a mission both simple and staggering: to map the very edge of the sun's domain, to chart the boundary between the familiar warmth of home and the dark, unknown ocean beyond. It was as if we were sending a scout to the edge of a great medieval kingdom, to peer beyond the ramparts and glimpse what lay in the uncharted lands outside. But how does one map the boundary of an invisible shield? How does one paint the outline of a bubble made not of walls and stone, but of plasma and magnetic fields? IBEX's answer was as elegant as it was brilliant. It would capture particles, neutral atoms, that drifted inward from the very edge of the heliosphere. By studying these silent messengers, IBEX could create a picture of the unseen border, a portrait of the sun's last reach into space. What it found was as humbling as it was wondrous. The heliosphere is not a perfect sphere, as once imagined. It is a distorted, asymmetric bubble, shaped by the pressure of interstellar winds, warped like a flame flickering in a cosmic breeze. It extends far beyond the orbit of Pluto, but even so, it is a mere speck within the vastness of the galaxy. Our solar system, for all its grandeur, is a tiny island fortress in a limitless ocean. At the edge of this bubble lies the heliopause, the final frontier where the solar wind strength is overpowered by the winds of interstellar space. It is there that the sun's authority ends, and the reign of the galaxy begins. IBEX's revelations were a stark reminder of how fragile our position truly is. The protective cocoon of the heliosphere shields us from cosmic rays that could otherwise strip away our atmosphere, damage our DNA, and disrupt the very chemistry that makes life possible. Without the heliosphere, Earth would be a barren, lifeless rock, a silent casualty in a universe indifferent to the dreams of living things. But the heliosphere is not eternal. It breathes with the cycles of the sun, it shrinks and swells with the changing tides of solar activity. And it is shaped, constantly, by forces from beyond our solar system, invisible rivers of gas and dust and magnetic fields that flow across the galaxy. We are not isolated. We are not alone. We exist within a dynamic, shifting neighborhood, a small but vibrant island caught between the pull of countless unseen currents. To gaze into the future is to confront the reality that the sun's protection may not last forever. As the solar wind weakens and the heliosphere contracts, more and more cosmic radiation will pierce through, altering the environment not only on Earth, but across the entire system we call home. Our technology, our health, even the climate itself may be shaped by these invisible forces. And yet, there is something profoundly beautiful about this knowledge. Because it places us in context. It reminds us that we are part of a larger story, a grand and unfolding epic that stretches from the fusion fires of the sun to the icy mysteries of interstellar space. We are not solitary beings, clinging to a random rock. We are children of a star, inhabitants of a sheltered, living bubble adrift within the galaxy. Our ancestors once huddled around fires, looking up at the stars with wonder and fear, sensing in their bones that the sky was alive with mysteries they could not yet name. And now, centuries later, we find ourselves naming those mysteries, mapping the very boundaries of the invisible world that has kept us safe. IBEX was just the beginning. New missions, new eyes, and new dreams will one day push even further, beyond the heliosphere, beyond the solar system, into the true deep of interstellar space. One day, perhaps, humanity will plant its flag not just on other planets, but in other star systems, carrying the legacy of Earth beyond the limits of our ancient protector. Until then, we remain here, spinning quietly in the golden embrace of the sun, shielded by an invisible wall, gazing outward into the endless dark, dreaming, as we always have, of what lies beyond. Our exploration of space leads us back to an ancient truth, that the sun has always been the life-giver, intimately connected to Earth's past and future. When we think about the story of life on Earth, it is easy to imagine it as a tale that began here, a local legend, born of oceans and mountains and forests. But the true story is far older, far grander. It is a story that stretches back beyond the Earth itself, beyond the birth of our sun, into the fiery forges of dying stars. Everything we are, every atom in our bodies, every element in our blood and bones, was once born in the heart of a star. In the final, violent breaths of ancient suns, the heavy elements were forged, hurled into the galaxy in great cosmic outbursts. From that stardust, new stars were born. New planets formed. And among them, one small, blue world, a fragile oasis where the dust of dead stars would awaken, breathe, and dream. Thus, our connection to the cosmos is not poetic metaphor. It is scientific fact. We are, quite literally, made of star stuff. And yet, our story did not end with the creation of Earth. It was only the beginning. From the very first moment the Earth cooled and oceans formed, the sun has been the great engine that drives everything. Its warmth prevented the planet from freezing into a lifeless ice ball. Its light fueled the first primitive organisms, sparking the earliest forms of photosynthesis. Through this miraculous process, sunlight was captured, stored, and transformed into chemical energy, the very foundation of the food chain that would one day support towering forests, swimming beasts, and thinking minds. Without the sun, life as we know it could never have arisen. Without the sun, the intricate web of ecosystems, the soaring eagles, the vast herds, the deep forests, would collapse into silence. The sun is not merely a background presence. It is the original energy source, the cosmic wellspring from which all earthly vitality flows. Every green leaf that ever unfurled, every heartbeat that ever raced, every breath ever drawn by any creature under the sky. All were, and are, powered by the light of the sun. Even fossil fuels, the black rivers of oil beneath the earth, the veins of coal woven through stone, are but ancient solar power, trapped and buried deep in the Earth's body over millions of years. Each gallon of gasoline, each lump of coal, is a time capsule of sunlight that fell on ferns and trees hundreds of millions of years ago. Plants that drank in the sun's energy grew toward its golden rays, died, and were buried under layers of earth, compressed by time and pressure into concentrated bundles of ancient sunlight. When we burn these fuels, we are, in a very real sense, unlocking sunlight from a forgotten age, releasing the energy of ancient days into the engines and furnaces of modern life. It is a marvel, a testament to the grand, interconnected web of existence. The roaring jets overhead, the hum of cities, the glowing lights that banish the night, all powered by the light of a long-lost sun. And yet, this immense gift comes with a price. For hundreds of millions of years, the carbon that plants had captured from the atmosphere was safely buried away, locked in stone and soil. But now, by burning these fossilized sunbeams, we are unleashing that ancient carbon back into the air in quantities far beyond the planet's natural rhythms. The result is global warming, a disturbance in the delicate balance that has kept Earth hospitable to life. The sun's warmth, once our savior, is now being trapped by a thickening blanket of greenhouse gases, leading to rising temperatures, shifting climates, and increasingly volatile weather. It is as if the very energy that once birthed life is now being twisted into a force of disruption, a reminder that even the greatest gifts of nature carry within them seeds of peril when misunderstood or misused. But here, too, lies hope. Because if we are wise enough to recognize our place in this grand story, if we remember that we are not separate from nature but a part of it, woven from the same cosmic cloth, then we can act. We can choose to live in greater harmony with the rhythms of the earth and the sun. We can tap into cleaner forms of solar energy, harness the winds and the tides, respect the delicate balance that has nurtured life for eons. We are not powerless. We are stardust that learned to dream. We are Earth's consciousness, gazing back toward the sun with understanding, with gratitude, and with a responsibility to protect the only home we have ever known. From the first spark of life in the ancient seas, to the towering civilizations of today, to the uncertain horizons of tomorrow, it has always been the sun, our ancient and cosmic companion, lighting our path, breathing energy into our dreams. And as we step into the future, may we never forget the golden thread that binds us to the stars, a thread that stretches across eons, across light years, whispering of our shared origins, and of the wonders still to come. Recognizing the sun's vital role, humanity now seeks to harness its power, building technologies that could sustain our civilization. Since the dawn of humanity, the sun has been a source of wonder, a blazing deity in the sky, a symbol of life, power, and rebirth. Ancient civilizations built monuments aligned with its path, the great pyramids of Egypt, the stone circles of Britain, the sun temples of the Inca. They understood, in their own ways, that life flowed from this golden giant. Yet for most of our history, we were able only to bask in its warmth, to plant our crops by its rhythms, to honor it with our myths. It was only in recent centuries that we began to dream bigger, to wonder, could we not only live under the sun, but harness it? Could we tap directly into the vast, endless energy pouring down upon us each day? And so began one of humanity's most beautiful endeavors, the quest to capture sunlight itself, to transform beams of light into power that could sustain our dreams without exhausting our world. The earliest attempts at harnessing solar energy were humble but ingenious. As far back as the 7th century BCE, magnifying glasses were used to concentrate sunlight and light fires. Ancient Greeks and Romans designed their homes with architecture that captured the sun's warmth in winter, an art they called passive solar heating. They knew, instinctively, that the sun was not merely to be honored, but to be woven into the fabric of daily life. Fast forward to the 19th century, the age of invention. Scientists like Augustin Mouchot and Frank Schumann imagined machines powered by the sun. Mouchot built solar steam engines in the 1860s, dreaming of a day when solar power could free humanity from its dependence on coal. Schumann constructed a solar thermal power station in Egypt in 1913, using mirrors to boil water and drive turbines. These early pioneers were glimpsing a future far ahead of their time, a future we are only beginning to realize now. Today, we stand on the shoulders of those visionaries, and the landscape of solar energy is nothing short of breathtaking. Solar thermal technologies capture the heat of the sun directly. Vast fields of mirrors, known as heliostats, track the sun across the sky, focusing its rays onto a central tower that can reach temperatures hot enough to melt metal. This heat is then used to produce steam, drive turbines, and generate electricity, clean, powerful, and abundant. It is as if humanity has learned to sculpt sunlight itself into rivers of energy. Solar panels, or photovoltaic cells, take a different, more magical-seeming approach. They transform sunlight not into heat, but directly into electricity. With no moving parts, no flames, no smoke, just pure, silent alchemy. Inside each solar cell, photons from the sun strike electrons and set them dancing, creating a flow of electric current. The sight of a rooftop covered in solar panels, glinting in the afternoon light, is more than a mark of modern technology. It is a quiet revolution. It is a testament to our ability to work with nature, rather than against it, to live by the gifts of the cosmos without exhausting the earth in return. And yet, even the rooftops and the solar farms are only the beginning. On the horizon lies a bold dream: solar satellites, colossal collectors of sunlight stationed in orbit, gathering the sun's energy without the interference of night or clouds, and beaming it down to Earth as microwave or laser energy. Science fiction? Perhaps once. But today, agencies and private companies are racing to make it real, sketching designs for space-based solar power stations that could one day light up entire cities from the heavens. The sun's power, once something we could only admire from afar, is becoming something we can weave into the very structure of civilization. And as we venture into this bright future, we are learning from the greatest teacher of all, nature herself. Consider the humble leaf of a spinach plant. It captures sunlight with astonishing efficiency, initiating the complex dance of photosynthesis that sustains almost all life on Earth. Scientists, inspired by this natural genius, have begun creating organic solar cells, lightweight, flexible panels made from carbon-based materials, designed to mimic the way plants absorb and convert sunlight. Unlike traditional silicon panels, organic solar cells can be printed like newspaper, wrapped around surfaces, integrated into clothing, windows, even vehicles. They whisper of a future where solar energy is not a distant, centralized system, but something woven seamlessly into the fabric of daily life, everywhere, effortless, alive. In the delicate veins of a spinach leaf, in the glittering arrays of a solar farm, in the shining dreams of satellites orbiting the Earth, there lies a single, timeless truth: the sun's gift is endless, boundless, overflowing. We are only beginning to learn how to catch its light in our hands, how to build a civilization that thrives not by depleting the earth, but by dancing in harmony with the sky. The story of solar energy is the story of humanity's awakening, an awakening to the possibility that the future need not be grim or diminished, but can be vibrant, abundant, and radiant. It is a story still being written, by every panel installed, by every innovation sparked, by every dreamer who looks up at the sky and sees not just a star, but a promise. A promise that, even after billions of years, the sun still shines for us. But even as we capture its energy, we must confront an inevitable reality, that one day, the sun will die, ending an era that gave us life. For billions of years, the sun has been our faithful guardian, a blazing heart that has warmed earth, nurtured life, and painted our skies with morning gold and evening fire. But like all living things, even stars are bound by the great cosmic cycle of birth, life, and death. The death of our sun will not be sudden, nor will it be violent in the way we imagine explosions and calamities. Instead, it will be a majestic, bittersweet transformation, a finale written across the heavens in grandeur and beauty. In roughly 5 billion years, the sun will begin to exhaust the hydrogen fuel at its core. Deprived of its sustaining energy, the balance between gravity and radiation will falter. The sun will swell, expanding far beyond the orbit it has kept for so long. It will become a red giant, a bloated, magnificent being whose outer layers glow with a ruddy, solemn light. Its surface will cool and redden, even as its sheer size becomes overwhelming, perhaps even engulfing Mercury, Venus, and possibly Earth itself. The sun, in its red giant phase, will be unrecognizable, but it will also be a testament to the incredible story of stellar evolution, written in glowing plasma and drifting gas. As the sun grows, Earth will face its own twilight. Our oceans will boil away, our atmosphere will be stripped into the void, and the surface will be scorched into a barren, molten wasteland. The planet that once teemed with laughter, forests, oceans, and dreams will be transformed into a silent rock, spiraling closer to the dying star. Yet, it is not only an end, it is part of a universal story of change. Just as autumn leaves must fall to make way for spring, Earth's end under the red giant's embrace will be the opening chapter of new beginnings elsewhere in the cosmos. In its final acts, the sun will cast off its outer layers into space, creating a planetary nebula, a breathtaking, ghostly cloud of gas and dust, expanding and shimmering like a cosmic lantern in the dark. What remains behind will be a white dwarf, a dense, hot ember no larger than Earth, but containing much of the sun's original mass. The white dwarf will glow softly for billions more years, slowly cooling, quietly waiting as the universe ages around it. It will no longer be a star in the traditional sense, but a memory, a monument, a relic of a glorious and irreplaceable past. And even then, even after the sun has faded into a whisper of light, its story will not truly end. The atoms forged in its heart, and in the hearts of ancient stars before it, are the very building blocks of life. You and I are made of stardust, the iron in our blood, the calcium in our bones, the oxygen we breathe. Every life, every song, every story on Earth is a continuation of that great stellar journey. The death of the sun will not erase the legacy of our world. Instead, it will carry it forward, scattering pieces of Earth's story across the galaxy. Somewhere, someday, in a distant corner of the universe, a new star might form, and around it, new planets may dance, perhaps even giving rise to new life, new wonders, and new dreams. The end of the sun is not merely a closing chapter, it is a cosmic handoff, a passing of the torch across eternity. A reminder that even in endings, there is beauty, hope, and the unbroken magic of becoming. Yet from the death of stars comes new beginnings, reminding us that we are all made of stardust, forever connected to the cosmos. As we come to the end of our story, a journey that began in the heart of the sun, traveled through the evolution of our world, and glimpsed the distant future of the stars, we find ourselves standing on the precipice of a cosmic revelation. We are not mere inhabitants of Earth. We are not mere observers of the universe. We are a part of it. We are woven from its very fabric. We are not just creatures that live on a planet, we are the heirs of stars. Every element that makes up your body, the iron in your blood, the calcium in your bones, the oxygen in your lungs, was born in the heart of a star. The very atoms that compose you have lived through the death of suns, traveled across galaxies, and woven their way into the creation of life itself. We are stardust, ancient fragments of a cosmic dance that stretches back to the beginning of time. The story of the elements is the story of stars, the stars that forged the building blocks of everything that has ever existed. In the fiery cores of stars, hydrogen fuses into helium, and as a star ages, it creates heavier elements like carbon, oxygen, silicon, and iron. These elements are forged through nuclear fusion, a process so powerful, so profound, that it is the very engine of creation in the universe. When these stars reach the end of their lives, when their fuel is exhausted and their light begins to fade, they explode in cataclysmic events known as supernovae. These stellar deaths are not just endings, they are rebirths. They scatter the heavy elements created within their cores across the universe, seeding new stars, new planets, and new life. This is where our story takes a profound turn. The elements scattered by these dying stars, the remnants of their bodies, do not simply float into the void. They are drawn together by the pull of gravity, gathering to form new stars, new solar systems, and new worlds. Our world is one of those worlds. The Earth, our home, was born from the remains of stars that lived and died long before our sun was even born. We are made of that ancient stardust. Every single one of us carries within us the legacy of a star's death, the story of cosmic rebirth. We are, each of us, a testament to the lives of those ancient, faraway suns that lived and died to give rise to the worlds that would eventually cradle life. We are the continuation of that great cosmic cycle, life and death, creation and destruction, an eternal loop that stretches through the ages. This is the greatest revelation of all, the deep, humbling truth that we are not isolated beings in a vast, indifferent universe. We are not just passengers on Earth, waiting for our time to pass. We are participants in the grand cosmic drama, a drama that began long before our ancestors stood upright, and one that will continue long after our world has passed. We are the culmination of billions of years of cosmic evolution. The very atoms in your body have been part of this universe for much longer than you can imagine. You are a living, breathing relic of a star that lived and died eons ago. You are a part of the great cosmic heritage that stretches back through the birth and death of galaxies, through the stellar nurseries and supernova explosions, through the nebulae and black holes, through every chapter of the universe's story. But we are more than just the products of cosmic processes. We are conscious beings, aware of our place in this grand tapestry, aware of the legacy we carry, and the responsibility we bear. We are the ones who have the capacity to understand the stars, to unravel the mysteries of the universe, to explore the cosmos and make meaning of the great unknown. Our existence is not a random occurrence. We are the universe becoming self-aware. We are the universe reflecting upon itself, gazing back at the stars from which we came. And this understanding, this deep, humbling awareness of our connection to the cosmos, is the greatest gift we have ever received. We are stardust. We are the echoes of dying stars, the whispers of the past carried across time and space. We are the dream of the universe, unfolding into being. Every heartbeat, every breath, every thought, is a part of the great cosmic symphony. And just as the stars live and die, creating the elements that make life possible, we too have a role to play in the ever-expanding story of existence. Our time on Earth may be fleeting, but the atoms that make us will endure. Our legacy will echo through the cosmos, carried on the solar winds of future generations. The light of the stars, the same light that gave birth to life on Earth, will continue to shine, guiding us toward a future yet unknown. We are stardust. We are not alone. We are part of something far greater, far older, far more magnificent than we could ever comprehend. And in this vast, awe-inspiring universe, we are both the question and the answer, the seekers and the finders, the children of the stars. As we look to the night sky, let us remember, we are not just observers of the universe. We are the universe, knowing itself. We are stardust, and we are home. If you've been captivated by the wonders of the universe, from the birth and death of stars to the cosmic dance of elements, and want to explore even more of the awe-inspiring science, history, and mysteries that shape our world, then be sure to subscribe to the Wonderology. Join us as we continue to uncover the marvels of our universe, spark curiosity, and dive deep into the incredible stories that await. Don't miss out on more amazing discoveries. Hit that subscribe button and stay curious.